bad glue ups, breaking bits, router mistakes, cracking a breadboard end, inappropriately using a metal lathe, failed tests, old-fashioned hand planing, modern wood tools. Now everyone says this, but this was the hardest woodworking project that I've done. My name's Corbin Dunn, and I'm gonna walk through my process in making this table. I'm always curious about where people get their ideas from, and I wanna talk about my inspiration. And I took heavy influence from Michael Kekovich's Foundations of Woodworking book, where he has an arched entryway table. I use that as a basis for my design, but I did modify it a bit, change the proportions, and I wanted to make it more challenging to build, so I added a lot more curves. Now Michael uses oak in his project, and I wanted to differentiate a bit, so I used some cherry and have a little bit of walnut as accents. I started by spending several weeks designing this thing in CAD. I use Autodesk Fusion, and if you want, you can go ahead and download the file for free. I'll share the files in case you want to try and check out how I designed it, so you can go ahead and maybe build it yourself. So I'm going to start out by making the Carcass sides and the top. And like normal, I start out on the joiner because I have to glue up some pretty wide pieces. The edge grain of wood doesn't need any additional joining for strength, but I use floating tenons to help with alignment. And you don't need to use a domino for something like this. A biscuit joiner would work just as good. And these short stubby pieces have to have the wood grain aligned with the Carcass top wood grain to allow it all to move in the same direction when humidity changes. I'm using 4/4 cherry lumber that has been pre-surfaced, S3S lumber, and I'll bring it down to the final thickness of 3/4 inch in a bit. I glued up the top and the bottom with the same method, using my 3D printed clamp stands to keep things aligned. After unclamping, these wide boards are slightly warped and not quite flat. They are too wide for my planer, so I flatten them on the CNC machine and bring them pretty close to my final thickness. Now my drum sander is wide enough to do these guys, so I ran it through there with 150 grit, so I wouldn't have to do as much sanding. I prefer the Intertape brand double-sided tape as it's easy to rip, and it isn't as gooey and thick like the X-Fasten brand stuff. So it was back to the CNC to cut out these rectangles just because I wanted to get them to the perfect size. But the inside dividers also needed a slight angle profile that I did with a ball nose bit. Now the top and the bottom of the Carcass have a curved front, which is easy to accurately cut out on the CNC, but the CNC also allowed me to precisely cut the drawer divider dados and a slot for the back piece to fit into. And it's probably good practice to cut out your dados before you do your profile pass, and so that's what I did. Now I can focus on cutting the dovetails on the Carcass, starting with the sides. I have a video dedicated on doing CNC dovetails, but one thing that I started doing was to stack the dovetails on top of each other and tape them together so I could cut them at the same time. I mount them up on my vertical work table and I squish them between two pieces of MDF to avoid chip out on the sides when I'm doing the cuts. I use a downcut bit to remove most of the waste, that way it leaves a clean top on the dovetails. Then I come back through with a dovetail bit to cut out the dovetail shape. The pinboard is my big top piece, and there's a curve on the front edge. I use the back edge for each of my machining operations, and that way I would have a very straight reference plane to indicate off of. So I set the Z0 to the top left edge, and then I jogged over to the right side to see if it was at the same point. And it turned out to be a little bit low, about 0.06 of an inch, and needed to go up, which was pretty easy to do with a wedge under the right side that I would just hammer up until it was right at 0. And then it was pretty much the same setup as the other dovetails I cut, squishing it between some MDF and then cutting it out. And the split dust boot design allows me to watch it a bit, make sure things are okay, and then toss on the other side and get good dust collection. Next, I wanted to glue up the Carcass, and I decided to finish sand the inside because there was no way I'd be able to do it after it was glued up, and I also thought I'd pre-finish it on the inside. So I masked off some of the areas where I didn't want to get any of the finish and put a coat of Osmo on. I did do a dry test fit and I had a solid plan, but this glue up went terribly. Off camera, I had cut and rabbited the back piece And since the grain orientation might cause some issues, it is not glued in at all and just free floats in those grooves that I cut earlier on the CNC machine. I start off by painting some glue on the dovetails and putting some into the slots for the drawer dividers. Now the dividers were just excessively tight in their grooves in the dados, and I really should have made them a little bit looser, so as soon as I try and pound one in, it would pop the other one up, and they just weren't seating down really where they needed to be, and this ended up causing some trouble later on that I'll talk about. But what was really the bad thing is I was struggling with them, and the glue on the dovetails was starting to dry, and so I went to try and pound in one of the sides with the dovetail edges, and it really just wasn't coming in as tight as I wanted, and did cause a little bit of push out on some of the wood, which wasn't great. Now luckily on the other side I actually forgot to add glue to it, and so it ended up not being an issue on the other side. The biggest problem that I was having here once I got to the clamping stage is that the middle was bowed up. The front and the back I could tighten down with some clamps, but the middle I really couldn't get to squish down. I tried putting some cowls on it, but it really just wasn't happening. I decided to route a slight chamfer on the top, and this ended up being a big issue. As soon as I started cutting, the router slipped down because I didn't tighten it enough and put a big gouge on the top of the piece. At the end, I'll show what I did to hide this. I needed to create a bunch of through tenons on the legs and base. I developed a good series of methods for getting clean cuts on the tenon that you will see on the outside as it pokes through, and also on the inside where it meets with the mortise. And so what I do is I use a downcut bit to first cut the top of the tenon, and that way it is nice and clean on the top. Then I switch to an upcut bit and just kind of kiss the whole outside just a little bit with that upcut bit, and that way it cuts a nice sharp edge. I then come back with that same upcut bit and just hog out the rest of the waste, and this gives me a nice clean tenon. I struggled a lot with the mortises in the legs and the rail. I broke my practically brand new downcut bit that was pretty long. It probably had a little bit too much sticking out, and I was getting a lot of chatter and probably doing too deep of a cut at 1/4 inch. I did have a shorter bit, but it could just barely make the full depth, and I was watching it really carefully. And the radius in the corner of these mortises is 1/8 of an inch, which is half of 1/4 inch, and I'm using a 1/4 inch bit. I think if I was to do this again, I'd make the radius bigger than 1/8 of an inch, so it could more easily cut those corners. Otherwise, it basically has to do a really tight 90-degree turn, and a lot of times you get a little overcut or a little undercut, and that causes some issues. After I cut all the mortises, I could come back and cut the profile. I did this for the front rails and also the legs, and it was pretty easy with leaving tabs and holding down the workpiece with some 3D printed toe clamps. Now the front curved rail was cut the same way, and the tricky part was how to cut the mortises on it. If I cut them when it was flat, they may not be the right dimension. They might be a little bit too thick or a little bit too thin. And there's ways of fixing that, but I decided to mount it vertically by just using my level to go ahead and get just basically a level plane and put the flat edges up against that and mount it. Then it was just a matter of indicating it in with my 3D sensor to find the origin for the X, Y, and Z. Now the cutting the tenons was the same as the other one, but some of them made it up to a curved surface and required a different machining strategy, and I ended up using the pencil to get the fine corners in and have it be curved. The front of the legs needed some more machining to have an area where the carcass could rest into, but as I was doing it, I was getting a lot of chip out, which was not great. And so my solution was to just support it with a piece of MDF, which ended up pulling up a bit through the cuts, and I only had to do 4 of these, well 3 because I already did one with chip out, and so I just kind of like held it in by hand a little bit as I was doing the cutting. This is a 1/4 inch spiral upcut bit that I'm using to do this job. I did a dry test fit of the legs and everything was looking pretty good, so I took it apart and then started sanding it, starting with 150 and then finishing off with 220. I could then glue together the top rail and stretchers, just putting some glue on the tenons and pounding it together, then taking it over to my clamp stands and clamping it up to let it dry overnight. I glued the stretcher between the side legs together in the same manner by putting glue on the mortise alone and squishing it together and letting it dry overnight. I did another dry fit, clamping it really tight together. I previously cut dowel holes when it was down on the CNC machine, and now I just put in a guide pen and tapped it a little bit to note where they are in the tenons. I could then take them back apart and mark the tenons just slightly inside, about 1/32 of an inch, drill them out, and this would allow me to have drawbore pins to tighten up the joints. I wanted to use walnut for the pins, and I didn't want to buy any, and I had some small pieces of walnut, so I just decided to use my metal lathe to turn it down to the right diameter. The leg glue up went really smooth because I kind of tested it a bunch, and it was fairly easy to do. The pins held it together really tight, and I really didn't need any clamps. And I even felt confident enough with it to just go ahead and trim the pins before it even dried. Next, I needed to attach the carcass to the legs, and I left the stock on the legs a little bit thick on the CNC machine so I could trim them to size. And I just used an X-Acto knife to scribe where it needed to be and trim them up with a shoulder plane. Then I marked and drilled some pinholes. I put some glue on the back side of it, and I glued and pinned it all together. And I'm really hoping that any wood movement on the top won't pull things apart. We will see. The drawer faces start out with some spoil board alignment holes, which have mirrored ones done into the top of the stock. I first machine out the front of the drawer face, put some dowels into those alignment holes, flip it over, and machine out the back of the drawer face. The drawer faces are held on with tabs. For the middle drawer, I realized I could cut out the half-blind dovetails at this time because everything was held perfectly in alignment. So I hacked off the ends of the stock piece to access it. Most of the material was roughed out with a downcut bit, and then I could come back with the dovetail bit to do the finishing pass. Going slow left a really clean half-blind dovetail, and at this time I also realized I should cut out the slot for the drawer bottom, and it's easier to do now because it's got a curve on this piece. The side drawers are not symmetrical, and the dovetails have to be cut perpendicular to the sides. I glued together two pieces of MDF to make a jig to hold them, and then I machined it out to have them at the exact correct angle. The sides would then fit perfectly into this jig, and I could do some clever clamping to hold it down. I put a little bit of blue tape over the ends because I was worried about chip out, but in the end that wasn't an issue at all. I started the machining process like before, using a downcut bit to remove most of the waste, and then coming back with a dovetail bit to cut the half-blind dovetails. Cutting out the matching half-blind dovetails in the side pieces proved to be really problematic. The pre-cut groove and the precise width of the sides just were not lining up with the fronts that are already cut out. Usually when you cut dovetails on a CNC or with a jig, you reference the same edge for matching doves to tails, but my method of cutting the drawer fronts didn't give me that reference, and I accidentally made them slightly non-symmetrical. So instead, I cut the sides to be slightly oversized, and I manually made the bottom groove line up by just chugging it out on the table saw until they fit perfectly. After I glued up the drawers, I went back with a plane and I just planed them down until they were the right size and fit perfectly into their drawer slots. The drawer bottoms are 3/8 of an inch solid maple cut out on the CNC because they're curved, and then I added a little profile with the router table and went back with a rabbet plane to clean it up until the drawers fit into the slots. I thought I did a good job of gluing up the drawers, and I did check for squareness while I was doing it. And of course, the drawer bottoms are actually not glued in, they are designed to float. But after the drawers dried, I realized they weren't quite square. I designed the drawers with 0 tolerance, and I knew this would make them a little bit tight and would allow me to plane the sides down a bit until they fit in just right. The fronts of the drawers were probably 100 thousandths of an inch, a little bit too far out on one side of each of the drawers. And this is because they weren't quite square. And I decided to just set the table on the back and plane it down. And this worked really well to plane them to be a perfect fit. The drawer pulls were machined out of a piece of walnut, and I had the side that faces the drawer up because it has the slight curve on it. I was thinking about gluing the drawer pulls on, but instead I just counterbored some holes and screwed them on. I cut the top out on the CNC like I did everything else. The hard part was how to cut the breadboard stub tenons and main tenons, and I decided to mount it vertically on the CNC table. There was a little bit of warp in the wood that I took out by using some clamps, and this is because I'm using 4/4 wood that was exactly 13/16 of an inch thick. And I had to be really careful to not let the gantry come too far forward, as it would have collided with my stock, but my 12 inches of Z-axis travel allowed me to pretty easily cut the stub tenons. The mortises on the breadboard end were also cut in the CNC, and I didn't leave any additional allowance for them. I wanted it to be really tight. And of course, one of my first tests of trying to put it in, I try to get it out and it stuck really hard, and I yank it too hard and break the breadboard end. And that's nothing that a little wood glue couldn't easily fix up. And then I just used my new shoulder plane to carefully remove little bits of the tenon until it fit pretty easily, but still a little bit tight. Breadboard ends have to be pinned. You can't glue them entirely on, so I clamped them really tight, set my Z clearances to be a really high clearance to avoid hitting the bit, and just went and drilled them out based on my CNC layouts in the CAD file. I then made a hokey jig for my plunge router to elongate those 2 end holes. I only glued on the center tenon, and then the ends, or all 3 of them, were pegged. Then I could go ahead and clean it up with a plane to make it perfectly flat. The ramifications of the bad Carcass Glue Up meant that it was rocky in the middle. So the ends were really flat, and I just clamped on some pieces of wood there and used my slab flattening jig and a big wide 2-inch bit to flatten the top where it was kind of proud in the middle. I still had some problems with the router slipping down a little bit deeper than I liked, so it was back to the hand plane to kind of get the rest of it smooth, which didn't take too long and was kind of fun to do. The next challenge was how to mount the top to the carcass, and I decided to just drill a few holes and use a couple of screws to mount it on. But the hard part was how to get to the back area to screw them on from inside where the drawers are. And my solution was to use a couple of bit extensions and a 90-degree I don't know what to call it, angle thing to go ahead and reach into the back to be able to screw things on and countersink. Before I actually screwed on the top, I did finish the entire thing. I used Osmo in the satin finish, and I put 2 coats on. And now some of the finished shots.